Sequences in Infinite Series, an overview, part 3. In part 1, we studied sequences and we continued that discussion in part 2. Here in part 3, we're going to discuss infinite series. This is the definition of an infinite series, and rather than reading this definition to you, what I'd like to do is demonstrate the definition. So the rest of this video will be a demonstration of what it means to have an infinite series or to find an infinite series. So let's get started. An infinite series starts with a sequence. We will start by looking at a sequence we looked at in our first video. A sub n equals 1 over 2 to the nth power. So a sub 1 is equal to 1/2. A sub 2 is equal to a fourth. The third term equals an eighth. And the fourth term equals 1 over 16. When we graphed the sequence, we saw that the terms get smaller and smaller and smaller in magnitude, and that the limit of the terms, as n gets larger and larger, the limit of the terms is 0. Now, the question becomes, what does it mean to sum or add up the terms of the sequence? Keep in mind that we have an infinite number of terms. So if you have an infinite number of objects, how in the world would you ever add them up? How is that possible? We start by adding up the first n terms. And let's go ahead and do that. If n equals 1, that means we're just looking at the first term. If n equals 2, that means we take the first term and add the second term. In this case, first term plus second term equals 3/4. Try to find s sub 3, the third partial sum. Try to find that on your own. The third partial sum is equal to the first term plus the second term plus the third term, which in this case adds up to 7 over 8. I have a nice graph here. The graph is a box that is 1 by 1. Notice that we have colored in half, a fourth, and an eighth. Notice what's missing. What's missing is 1/8. Let's do this for n equals 7. If n equals 7, that means that we take the first term and add the second term and the third term and the fourth term and the fifth and the sixth and the seventh. If we add up the first 7 terms, what do we get? Adding up the first 7 terms, we get 127 over 128. Another way of looking at this might be to say, what is missing from the box? We have a 1 by 1 box, so the area of the box is 1. What's the area of the rectangle that is missing? The area of the piece that is missing is is 1 over 128, or 1 over 2 to the 7th. So the 7th partial sum could be written as 127 over 128, or it could be written as 1 minus 1 over 2 to the 7th. And in general, the nth partial sum is equal to 1 minus, the rectangle that's missing would be 1 over 2 to the n. Next, what we do, but keep in mind our goal is to add up an infinite number of terms. So what we do is we add up the first n terms And then we say, what happens when n goes to infinity? And in this case, when n goes to infinity, we get 1. So this is the same as saying that the infinite series converges, and it converges to a value of 1. Now, before we finish up, I want to give you some analogies that might be helpful to you as you proceed in this chapter. We've already discussed how a sequence is like a function. So a sequence is analogous to a function. It is like a function. With a sequence, your domain is positive integers or integers that start at 0, or the domain's going to be the integers, whereas with functions it could be, any real number. So the domain of a sequence involves integers. So a sequence is like a function. A finite sum, if you were to add up the first n terms, that would be analogous to an integral. Because what's an integral? An integral is just adding things up. And the same thing here. A partial sum is just adding things up. Now, a series, which has an infinite number of terms that you're adding up, a series is analogous to an improper integral. And do you remember how we did an improper integral? For an improper integral, we found the finite integral, say from 0 to b, and then we had b go to infinity. And that's exactly what we do here. We find the finite sum, and then we have n go to infinity. So this section here we've been looking at is just an overview. We'll go into depth into all of these issues more thoroughly in the sections ahead. Take care and have a great day.